All right, so today's session we will commence with the one of the object-oriented concept, the polymorphism. I'm sure everyone knows it. I have already spoke this one in the last session, but we are still using this polymorphism every time when we are using the concept of explaining the concept of object-oriented programming. So this is a main, is a polymorphism is a core concept actually. So it is generally means many forms. So anything which behaves, I mean, like a exist more than one form, right? So you have some example like methods, basically methods or functions which behaves differently in different context, in different times, in different okay. So that's a polymorphism. Basically, a person like me, I say I can behave differently in different times. So that's an example of polymorphism. Anyway, what is a polymorphism? A polymorphism lets one method in Java definition, you can say one method or a function perform different tasks based on the object or data. Okay, it works with, okay. So based on the data you provide, based on the object you're calling, so it will work differently. Okay, that's the polymorphisms. It behave differently. Okay, so there are two types of polymorphism. One is compile time polymorphism, another is runtime polymorphism. We have completed already. This is a part of the first two sessions. So this is explained through the concept of method overloading. What is method overloading? A method with same name with a different signature. That's the method loading within the same class. Within the same class, we have seen this one, right? So we have a lot of examples available in the blackboard as a task, as in the exercises. So we have completed this one, static. Why it is called static? Because at compile time, the already it knows the which method has to call. It is as because of different signature within the same class. So this is compile time polymorphism. Now we have runtime polymorphism. Now, runtime polymorphism can be explained with different concepts: concept of inheritance, concept of abstract, concept of interfaces, right? So runtime polymorphism, we based on the object calling, based on the data, we can call the methods, we can execute the method, right? Within the different classes, not the same class, with the different classes. Okay, but different class means it is having some relationship. Okay, it's like inheritance or abstract or interfaces. So this is runtime. So method calling a method during runtime, it's like a during interpretation of method invocation, or dynamic, or is also known as dynamic polymorphism, or late binding. Also you can say late binding. What is dynamic method dispatch, or you can say dynamic polymorphism, is also known as dynamic method dispatch, through the concept of abstract and interfaces. Inshallah, we'll see this interface next week. All right, so through the concept of abstract here, in this one, the object of a superclass refers to the object of a subclass. So I will explain to you this one. Okay, what is object of superclass? Is like instance. I can say instance, or instance of a superclass. Object, I can say object also. Can say anything, right? The instance of a superclass refer to the object of subclass. Okay, this is the main core concept of dynamic method dispatch, or you can say runtime polymorphism. Okay, so let's see. Before proceed this one, we'll go with one more concept. There is another concept is abstract class, right? So along with the polymorphism, abstract class, I will explain the concept of abstract class plus runtime polymorphism, both. So single same program. So what is abstract class here? Abstract class is again is a object oriented programming concept. In this one, it's a class. It's a class that cannot be instantiated directly here. So I cannot create an object of abstract class. I have a class. A class has variables and a class has methods, right? So but when I declare a class an abstract, when I say this class is become an abstract, means the methods, I mean this class, we cannot create object. Now once you cannot create object, you cannot access the methods, and you cannot access the members. It's very clear, right? So you cannot access. the methods as well as members, but you just what you say, you just declare it. You're making it for declaration. In English, what you say abstract means you define something without much detail, no details. You not define the details. Okay, or declare something in your project, but without in detail. You just define abstract overview or a very some kind of definition, you small definition, one paragraph, two paragraph, that's it. But you cannot implement, you cannot show the what is in detail. The detailed implementation is hidden from the user. So this is called abstract in general English. So it's same case in programming. Java abstract class is an object-oriented programming that cannot be instantiated directly, but we can do something internally, right? So and it designed to be inherited by other classes. How do you, I mean, how do you implement this, and how do you execute this one? How do you implement this abstract class? You need to create a subclass. Simple thing. You need to create a subclass implementation class. Then it is called implementation class, right? It may contains. So what is abstract class consists? Abstract class consists abstract methods as well as concrete methods. Okay, an instance variable and construct. It can have anything. It's like a class, a simple thing, but you cannot create objects. Just keep in mind. And the methods in abstract class has two types. It's general methods, like concrete method means fully implemented methods. It has body, it is doing some work, operations, something. It's like what we did regularly. Okay, but abstract methods declared, just declared without implementation, no body, just declared. Okay, so this is abstract. What is the purpose of this one? What is the purpose of this abstract class? This is the question, right? It provides a common template, a blueprint. It act as a blueprint, a template, a form, a model, you know, for subclasses, forcing them to implement specific method. Okay, while sharing common functionality. This is a concept. Generally, this is the concept of you say uh, polymorphism, runtime polymorphism. You have a method declared as abstract in the abstract class. Now you create a subclass. You can create multiple subclass. Now that method is a model, it is a blueprint, it is a template. So the subclasses are forced, you must implement the logic or implement our body in the subclasses. Okay, that gives some functionality, that gives some implementation body to the abstract. Let me show you with the help of example here. So let's say abstract here. Let's go to the new. So it's a class, abstract class. We do not have abstract class, but we can make a class as an abstract class, just a class. Example here. Let's say any example. I will go very simple example here. Shapes, right? So this is the shape here. Different shapes you can have. Subject. So let me do this part. Try to understand the concept here. So in the shapes, it's a class, right? So shape has, I will go simple class, then I will make it as abstract class so that you can understand the concept as well. As shape has two methods. Example here, public void draw. I'm drawing a shape, right? You can say here s out drawing a shape.
Victor,
Yes.
we can't see the program.
Okay. Okay. Thank you. Thank you. I think I will reshare the screen, whole screen. I forgot that part. I think now you can see, right?
Yes.
Yes. Sorry. Thank you for that. So now I have a class shape and it has a method, right? So how do you call this method? You know, everyone knows. I'm going very basic from the basic part. Now you say class test. Now you call PSVM. Then you say you create an object, shapes, s equal to new shapes. Now you call the method s dot draw, as we know everyone from the beginning, right? So you run the program, you will see the drawing a shape. Sorry, this one is the file. Just keep running the other file. Okay, the shapes. Maybe I have some different test programs everywhere. You can say test 2. Yeah, because see, this is, you may face the same issue, right? So when we have another, in another any package, anything I have test, so it is running the other class, okay, with the test same name. So I just change the name of this test class, so I can now they're drawing a shape. Everyone knows this one. But what if I in this case, what you are doing here, okay, let's you're taking here public, or just say public class, like single inheritance, public class, uh, shape, like with shape rectangle. Triangle, you say extends shapes. Right now, extending means, it means you are implementing the same thing here. Okay, it's okay, that's not necessary. And you are implementing now, drawing a shape, drawing a rectangle, drawing the rectangle here. It is just taking the name as okay. All right, so it's taking different because of public. Let me remove this public. Right, so now it's clear, it's gone. All right, so now here a triangle, rectangle. Now when I call the shapes, now since we have rectangle here, I call the rectangle, rectangle, rectangle. Now you say s dot draw. Now it will go to the rectangle. I just say run the file. It will run the drawing a rectangle. You see. Now when I make a shape, okay, so shape, so shapes s equal to new shapes. Right now this is shape and this is rectangle r, as I'm just taking here r dot sorry, s dot, you say draw. You see, right? So based on the object I can execute the body, based on the object. This is called runtime polymorphism. Based on the object, it will decide which method to invoke. Now s dot, s is a shape object, right? So it will go to the shape draw based on the, again here r is an object of rectangle. So when you're calling r, sorry, here this is r, then it will call the method draw of the rectangle. This is called runtime polymorphism. This is what I show you here. It in this one, dynamic method, the sub instance, okay. But this is based on the method inheritance. This is a kind of method overriding. Let's see your abstract class later. So this is method overriding. Now I have one more method, example here, public area, calculate public divide. I'm just taking very simple here, calculate area of shape. Okay, so this is some methods I defining here. Now I say here, look here, I am defining a method, a template method, calculate area. Right, so I just want to make, it's like I want to make this as a template, as a blueprint, so that any subclass, I have only one subclass here, can implement its own logic by extending, overriding the method, like they implemented the draw method. Okay, now calculate the area. This is general shapes here. Different shapes, rectangle, square, trapezoid, different shapes we have. So this is a blueprint. This is like a blueprint, a blueprint or a model, so that it can be extended by its subclass to add its own implementation, its own behavior, its own body. Okay, that's the main purpose here. Now I can add this one here, here example here, public void calculate area. Now here is calculating some area. Example here, south area is equal to shape area. Shape area, something you give, say 4 multiply 5, some area. This is some random calculation here. Now I have the same thing here, S out area of rectangle is like, 5 multiply 5 multiply uh, plus 5, just say plus 4 something. This is some formula, assume. So I can have this area has different calculation area, like similar draw. Okay, so this is a blueprint. Basically it does not provide, assume this does not provide any data, any details, but still I can override. Can you see here? I can override. This doesn't have, there is no calculating area of a shape. What shape you are talking about? So you say I am talking about a shape of rectangle. Okay, this is a rectangle, length into breadth into height something, length breadth height something, like some formula. Okay, so here it doesn't provide anything, it's empty, there is no purpose here. For such methods are called abstract methods. They are called abstract methods. If you don't want to provide body, okay, let me this one, remove this one, remove this part, and just give a semicolon. I say I'm just declare as abstract, abstract. Now this is an abstract method. This is called an abstract method. Don't provide any body here. There is no body here. This is what I explain here. Here, abstract method. A method declare, just give the name without implementation, without body. And what is a method? A concrete method fully implemented. Here the concrete is drawing. It has all implementation. It has some code. It has some body here. Okay, so this is a, now it's giving error here. What is the error here? Shape is not abstract and does not override abstract method calculate area in shapes. So shape is not abstract because you have abstract declared here method. So this abstract must be in the class abstract. As error. So this class shape is an abstract class. So it has a abstract method and concrete method. So I just say here for knowledge, concrete method. This is abstract method. How do you declare, how do you make this an abstract? By just keyword abstract. This is abstract method. All right, so let me put this part. I just remove this two. Okay, okay, so now you define, look, now you define a method shape and you say I have a concrete method and I have a abstract method. Two methods are available in the abstract class, class name shape. Now you are enforcing here. It provides a template. Now this is a template. Now for subclasses, forcing them to implement, forcing, you are forcing now any subclass which is extending the abstract class, any subclass extending the shape abstract class must override the method, abstract method must override. Okay, let's see here. So it's giving error. You see here, rectangle is not abstract and does not override the abstract method calculate area. Read the error here. So it wants to, you must implement. Okay, so how do you override? Just, you have insert code. I just type it, no problem. Insert override the method. Which method? You say here, it's not giving here, or you can say insert code, implement method calculate area, implement, just giving here override. Now this is just simply delete. Now I can say here I must override. For example, here you say I can say south, I say area of rectangle is, I just press here, rectangle is something 4 That's it, 4.5. I just give an answer here because not calculating and just printing here, right? So this is one thing here. You see, now implementation done, all is okay. So if you have any method abstract class and you're extending this rectangle, you must override. You must override. It's not necessary to override this one. Is it clear? So this is called an abstract class and abstract method. Okay, let me do one more thing here. Let make this one also abstract. So this is an abstract, so I remove the concrete. I'll make it as a abstract. So you must declare as abstract abstract. So this abstract class has two abstract methods. Now it's giving error here again. Why? Because you did not implement draw. You did not implement draw, right? So either you implement here inside this rectangle, or you now if you don't declare here, for example, you don't want it, then you must declare a class as abstract again. So because you are implementing only calculate area, you are not implementing the draw, because it's also an abstract. Now it became abstract because you remove the body. Is that clear? If you have, so you are forced to implement the abstract methods in the subclasses. Now if you don't implement, you must declare as a abstract. Hope it's very clear. All right, then what is solution? You need to create one more class. You need to create one more class and implement these both methods. Okay, you can try this by yourself. Okay, so you can just create another class as a class square extends shapes, or you can extends rectangle. Okay, now open this part. Now you say right click, insert code, implement draw method, problem solved. Now you just remove this part and just let me make this one small. All right, so here I can write here so drawing a square shape. Clear? So I'm using the third class which is extending the rectangle. Now we have implemented the calculate area, we have implemented the draw, right? Or if you write it here shapes, again gives error because you need to implement again calculate area. So it depends how you design the program, what is your question, and how do you implement this part. Okay, this is one way. So let me just to make it myself easy, I just want it sorry, I just want this code. Let me take this code. Okay, I will just add it here inside the main class. I will remove this part here. So I'm implementing instead of star, I'm just drawing a rectangle to make the code shorter, Now you see, since the shape is a abstract, by the definition, abstract is a class object, an object that cannot be instantiated directly. You cannot create an object simply. So you see, it's giving error here. You just keep the abstract shape is abstract, cannot be instantiated. Cannot be instantiated. Okay, so you cannot create object directly. Again, all right. So again, the rectangle also abstract. So just remove this abstract because it's implementation class. Now rectangle is okay. We cannot create object for this one. Let me put this way. Okay, I cannot create object for this one. I can add a rectangle object. How do you create object? Let's see. How do you create object? By default, what you're going to do here is rectangle, as what we practice, r equal to new rectangle. You say yes, r dot, you say calculate area, again r dot, you say draw, right? So this is how you call the two methods, right? So you're just creating an object and calling here, right? So if you have two objects, for example, you create one more class or one more thing. Okay, one more class. Okay, because since I cannot show you the demonstrate more, I can create sorry, this part. I just say here I will take this thing, same thing, copy. I will create one more shape. I can say square. I'm extending the shapes. Okay, it's like multi-level. This is square, uh, and this I can say 14.5 and square shape. Same thing, right? So have this part. So how do you use it? Then you have to create an object. Look here. You need to create. This is the you created object for rectangle. Again, you need to create object of square. Square is equal to new square. Then you say s dot calculate. Then s dot draw. Sorry, draw. So yeah, it will print. You see, it will print the both objects. Area of rectangle for drawing a rectangle shape. Okay, area of square is 4.14.5 and drawing the shape, right? Square shape. Here square shape and here rectangle shape. You are implementing one method, is implementing one object is for this one, but you're calling the same methods. But this is not the way I'm just want to show you here is this part. This part I want to show you. Dynamic method this part. The instance of superclass refer or object superclass refer to the object of subclass. Okay. Or I can say here, how do you create object here? This is the way you create the object, right? So instead of rectangle here, I can say here shape. I can write a shape s equal to new rectangle. Shapes, not shape, it is shapes. Now you see here, I just remove this part. Now this is what? This is a superclass. Superclass variable. Superclass, this is called reference variable. Reference or instance variable. S is, sorry, S is a superclass instance or object. Generally, if you think it is object, that's object. You cannot create object directly. I said you cannot write it object directly, right? So basically, once again I will write it this one here. You cannot create shapes s equal to new shapes. It gives error very simply because it is a abstract class. So this part you cannot create. So what you're doing here, you're just creating s and you're referring to the subclass object. This is a subclass. Rectangle is a subclass. Extending shape, right? Similarly, you can create one more shape s2. For example, this is s1 and this is s2 equal to new square, another subclass. Okay, so this is s2, s1 and s2 is also a superclass object. Right? So now let's see, s1 dot same superclass object is calculating area. Now what is the output? Since s1 is referring, it is pointing to the object of rectangle, so it will calculate the rectangle. Just let make it show just simply here s1 dot draw, right? So s1 dot draw, so it will look s1 dot, what is s1? It is referring to the object of rectangle, so rectangle here, so it will call the rectangle draw method, right? Let's run the program. You see here, drawing a rectangle, you see. Okay, now dynamically I can say s2 dot, again another object referring to the draw, which s2 is referring to the object of the square. So run the file, it will print the square. Okay, or you can write like this, shape s, right? Now you say s, here s, remove this s, just like a variable declaration. Now I just remove s, because it's duplication, create a duplication shapes, sorry, right? So assign value never be used. Okay, so this is again, you have to better, you may go with the same s1 s2. Okay, this part is not necessary, unnecessary opening. Okay, so hope it's clear. Now based on the object is holding, now this s1 is holding the object of rectangle class, s2 is holding or referring, I can say referring to the object of sub, so it will call the method. So based on the method, this is what is clearly mentioned in the definition here, the instance. Okay, says here polymorphism let one method function perform different task. One is printing rectangle or printing the square based on the object or data it works with, it works. Okay, so hope the definition is very clear. So this is called abstract class, abstract keyword, abstract methods. If a abstract has abstract methods, then without body, this body has to be implemented by, so this is like a design, a template. So I have the shape. Now you create a rectangle shape, rectangle area, square shape, drawing the square and calculate the area of the square. Right, this is a testing program. Basically you need to have separate classes. Okay, just I, because I, to make it explain, I kept it in the same file. Okay, so hope it is very clear.